streaming. We are live now.
I think so. Looks promising.
Yeah.
Let me see. Refresh 3 times. And then Twitch will know. Then Twitch will know. There we go. Well, there. Hey. Okay, I'm gonna share my screen. Okay. So today we're going to do some LeetCode exercises in Lean, and yeah, I don't know if Lean was really built for this. It was pretty low on the priority list if it was. But it is interesting that you can do a lot of imperative programming in Lean. So let's see how well it can do it by doing some LeetCode exercises, and that way everyone is kind of on the same page and we are just evaluating the imperative programming. So for example, okay, first to get a script to run in Lean is kind of, well, you need 3 files. You need a lake file to just tell it which one your main is and things like this. I don't know. This is copy and paste this. Then you need your Lean toolchain to just specify which version of Lean you're actually using. And then you need your main, right? So this is a main that's just printing out hello. We should say world, right? Otherwise it's wrong. And then you can nuke your build folder that you prepared in the oven. And then you can say lake build, and lake is the make of Lean. And these are just warnings that I don't understand, so I'm not going to care about them for now. And then you just run your app that's been built. There we go. Hello world.
What's the S exclamation mark before the string literal?
Oh, I think this is for string interpolation. Maybe we don't need that.
Okay, looked like a typo.
Yeah, there we go. So I think if you go late x equal 1 or world, and then you go this, I think you can do string interpolation. There we go. Hello world. I guess we should say hello x, and yeah, there we go. Hello x. Yeah, so that's just how you just run a script in Go in Lean. Sorry, doing too much Go recently. But yeah, that's how you do just a little imperative main function in Lean. And this is all in the IO monad, but unlike in Haskell, where this is quite the pain to work with, or just not a pain, but like hard to explain, I guess. In Lean, you don't really need to understand it that well as you need to do in Haskell, because there's a lot of macro magic going on in the background that makes you able to just write imperative code as you're kind of used to, almost. But yeah, we'll see more of that as we try to attempt some exercises. So Paul's gonna take over, right?
Yeah.
Yes, and because he's more versed in LeetCode than I am. I'm not that good at it, but we'll see. We'll see. Maybe I can help.
Well,
and then
sure.
then I'm gonna try to redo what he does and see how as the speed of Lean compares with another language, and the one I know the best is Go. So I'm gonna pitch the two against each other. So we see like the runtime speed as well. How does that sound?
Good.
Good. All right. I'll stop sharing and then you can, or yeah, you can just take over. There we go.
Discord. I was expecting to see. Close Discord. Okay.
Cool.
So here's the one I made earlier.
Uh-huh.
So we have the LeetCode here. So LeetCode is this horrific website full of horrific things.
Hey, we all love it. We all love it. It's everyone's favorite website.
Right, hold on. So we just move this. How do I move the controls? The Zoom controls.
You can't see them on the stream.
No, but
they
okay.
are.
So then what I did, I picked this one to sum. So we have an array of integers, an integer target. We return the indices of the two numbers.
Let me just zoom in like one level. Yeah, there we go. Nice. You can zoom back out one level. That seems a bit squashed.
Okay.
Yeah, nice. That's good.
So here, no. So here we give this array of numbers. We have to find the indices of the two numbers that add up to 9. So here we should get 0 and 1. And just to get us started, I wrote this in Lean using the imperative stuff. Well, first I used the lake init command to generate all of the gubbins. So
that's what I should have done.
Yeah. So it does this.
And
you see how it's got this backtick. I don't know what that means, but I saw it in yours as well. So it's not it's not a typo.
No.
So and then you get this.
I think the backtick is just a way to make a string. I think you can remove it and put main in quotes. And
interesting.
Then, like you can try that. It should be kind of the same.
Yeah. Don't want to restart Lean. Everything was working. Now it will probably break. So if I go back to this one, I assume that means it's still working. I see. So it's like you have like a symbol or something.
Yeah. It's just it's just quicker to write strings that don't have spaces this way.
I see. I could have done something similar here. Anyway, the other thing is I don't know why it gets this braces.
Yeah, that I don't know.
I don't know. Anyway, that's what it generated for me. So you get a package called LeetCode with these braces around it. And then we get a library called capital L LeetCode. And then we get an executable called LeetCode. I don't have, I do have a main. Okay.
Yeah, there you go.
Oh, and then it's, so, but it imports this with the, I don't know whether that is part of the name or not.
It's part of the
name.
Maybe
it's another way of, so the name is weird brace, LeetCode, weird brace.
Yeah. I think okay. So. If you go back to like file.
So if I change that to like remove the braces.
Well, then maybe one last check. Also check LeetCode.lean. There's no name.
I'm not using the library. Oh no, this is where the library is defined. Presumably that was also created. I can import. So can I use the to sum here? Yeah.
Yeah.
So I don't know what that means. Maybe it's another thing where our imports usually have quote marks around them.
No,
No.
I've not used this. I've
Oh,
not
okay.
but
Anyway,
yeah.
that was all just generated.
Yeah,
And then I
interesting.
just added the standard library.
Oh, nice. Yeah, good idea.
Okay, so now we use the weird imperative stuff from Lean
Yeah.
and mutability. So just normal function, and I'm using array here
Mm.
instead of list.
Mm. Which is an
It's
array.
meant to be runtime performant.
Ah, yeah.
It's not a linked list. It's actually I think
Mm.
it's actually an array.
Yeah, so for the sake of proofs, it is a list, but
Yes.
for the sake of the compiler, it is an array. Yeah, nice.
Yeah.
Perfect.
I'm using that one. Yeah, so it's claiming here has comparable performance to mutable arrays in imperative programming languages.
Okay, yeah, that's what we're definitely going to need that for LeetCode exercises.
So yeah, so we got an array, a target, return a pair of indices. So here is natural numbers. And then we are, I don't know what monad we're in here. So at this point, I was just mashing the keyboard. But here we are in pure world. We're not in IO. So
yeah.
we've got this ID.run.
Yeah.
And then this is we have this in Haskell as well.
So you're in the ID monad.
Yes.
Because if you go to ID run, if you click on click on it, oh, okay, it doesn't always work.
Yeah, monad ID. Okay.
Yeah.
Great.
Yeah, which is basically just nothing. But you can write do syntax now.
Yes. So the aim was to get the do syntax so I can use the for and the whatever.
The imperative stuff.
The imperative stuff. So then we can create a hash map. So
a mutable one.
I don't know whether you're meant to do this. I don't know whether you can combine these two lines or not. I don't remember. But import stud, and then I don't want to say stud.hashmap, so I'm just importing that.
I like it. I also forgot if you need it or not, but
yeah. So I don't know if you can say.
I couldn't figure it out.
Import stud open. Yeah.
But yeah, don't. Yeah, I think it's
interesting whether you can combine the two. It doesn't look like you can.
It's okay. It looks good. It's good enough for today.
Yeah. So then we can say for I in 0, and that this doesn't include the top of the range, as far as I can tell. This
beautiful.
But not including values.size.
Yeah.
And then we can do things like, let's get the I element. And then we put this bang here to say, I don't care what if this, because we're told in advance well, in this case, we know. I think in general, this array thing, we would have to provide a proof. Yeah, there's a get. Yeah, get. Accessing an element from an array without bounds checks using a fin index.
Yeah.
Which is effectively a proof that the index is within the bounds of the size of the array.
Yeah.
So you have to provide an index in fin a.size. This is using dependent types. Interesting. Maybe we can actually use that.
Yeah.
And then there's this thing, access element for array with the default.
Yeah.
And then I'm using this one here, which is
I think it infers the default. So the elements in the array implement the inhabited class. So if we find the implementation of net, the natural numbers inhabited class, like then we'll know what the default is. But
but
probably
you pass it
0.
an argument though, do you?
Yes. But
So
if you look at the array get capital just below, it calls get default.
I see.
And it passes the default argument. The default argument is inferred from the inhabited type, the inhabited class. So you don't actually have to pass the default to array get exclamation mark.
But the default must be panic then.
No,
it just panics if the index is out of bounds according to the documentation.
Oh,
So this thing, does this thing panic then if it can't find such an inhabit?
I don't think it panics. I think net is inhabited.
Okay, so let's try.
Maybe I forgot. Yeah, let's test.
Can I do stuff at the top level? Can I use let at the top level?
No, but you can do it in your main.lean.
Oh yeah. Oh, I need to remember it's a silent symbol.
Oh, okay, yeah.
So I say 2.
And then just print v. You can even print v, yeah. Instead of the hello.
Yeah.
Oh yeah. Cool.
How do I run this now?
Now you go into your terminal. Okay.
No, it's not what I want.
I think it's Control-Shift-Tick. Those 3 buttons in the corner, the bottom left corner of your keyboard. Or you go,
yeah.
Or you click on the menu terminal and just say new term, like
okay.
Terminal, new terminal here. Yeah, there you go.
Right. Lake build.
Yeah. Cool. Those are just warnings. No. Now you go /build .bin and then yeah. Okay. Nice. I was wrong.
What? It should panic with a panic. It shouldn't segfold. That's not a panic.
That's kind of the same.
No.
Okay. Remove the weird.
I don't. Right. Let's see. I think we found a compiler. That's a compiler bug.
You don't like segfaults?
No.
I mean,
what? You think that's acceptable?
No, I've not seen a segmentation fault in years.
I have.
But
I've written a few seg faults. Written a few bugs producing seg faults recently.
Okay.
But I don't think it. Okay.
It's a panic. It's not a nice panic.
Looks like something else has gone wrong.
Yeah.
Because we don't know, anyway. Okay, so it's clearly not this default thing.
Yeah.
Assuming that is the get ln. Right. So get ln.
Oh, it's not the array.
Assuming that is the same thing. Right. So let's try get exclamation. I was assuming it was the same thing. Oh, what do you pass it? Oh, sorry. Oh, we have to.
I feel like that's
Can't we
right.
do that? Yes, because it's this thing
Oh.
here, isn't it? Then we give it a NAT. And what's the error actually say? Oh, I'm not using. We got the semicolon.
No. How did we call? Can you go back to LeetCode.lean? I just need to see some.
Yeah. So I was using this, but I thought that
Hmm.
was a sort of hook. But this here, h.find.
Yeah. So you just need
no, it's a self parameter. So
Yeah.
maybe I have to use get with a. I can't use it with that.
No. I
form.
think you just need space to 0. I think that's all.
Oh, okay.
Now you can
Why
go
is it
back
over
to
here
line.
now. I don't know the job there. Yeah. I was getting confused. I thought it was doing imperative programming so much that I can't do the function calls right anymore.
No.
It's very well disguised.
Yes.
Okay, let's try this again. Let's try 2. What would be a good outcome for this?
There we go. Oh,
This. I don't know. This is going to delight a Go programmer.
yes.
But nobody else. Everyone else is going to be unsatisfied with this default 0 values.
Well, you can just use the question mark and get what you wanted. Like, that's probably what you want.
Yeah.
Okay.
Yes.
Don't worry.
Exactly.
And
well, what I wanted in this case, we can just use this.
Yeah.
But
because we know.
But what I would like to know is like how we would use the safe version.
Yeah.
Given how do we get a fin out? But anyway, that this is just naive translation of the thing. But it's quite neat. You can do this for loop.
Yeah.
And then you would say, I'm using find here. So you get an option NAT. And we just do a match construction. We find it. We can do this early return. This return from the whole function.
Yes.
It's really nice.
Yeah.
You don't have to like. Well, I don't know. I mean, you can also use break and continue in this for loop. Otherwise, we mutate the hash map.
Yes. And we insert the value, the I at the value.
Yes. Because what we do, we look up. What we want to return is the indices. So they are the values of the hash map. And the keys are the things that we're looking for. So we're looking for the complement of the target as the key.
Yeah, I think I still don't understand the question. Maybe let me just.
Yeah. Let's go back to the question.
Yeah.
So we have an array of integers.
Yeah.
And a target. So we return the indices of the two numbers such that they add up to the target.
Oh, okay.
So we want this. The one is 0 and 1 for this one. So what we store is like the complement.
Yes.
What we look for is the complement. And this value that we're storing is the complement for another index. So for two, for example, we store 7 because it's the complement of the target. So when we get to 7, we look up 7 and we get a 0.
Okay.
So we got, that's the idea.
All right. I'm gonna. So how do we have an example that's kind of stressing this? Like, does LeetCode provide any large examples?
No.
These
are the 3 examples it provides. So we can try to generate more stuff for your benchmarking purposes.
Yeah, it would be nice. Let me see if I can find something to some.
Yeah, and then finally this thing hangs at the end because you need to, this do block needs to evaluate to something.
Oh,
I guess you would write, well, you want it with pure maybe, something, but it's the same.
okay. I
So
see.
you have
So,
this like, this needs to be here because otherwise it's going to complain and say like you're not,
we're not always returning.
Yes, exactly. Where in effect this is impossible given the statement of the problem.
Yeah.
So
So
we know
basically,
it's exactly one solution.
yeah. But yeah, actually, we want to return option of net because there might not be one.
But it says there is one.
Okay, there is one. Okay.
So we should actually, what should we do here in that case? We should explode. Don't know if there's an error.
I think there's a throw.
Oh yeah, throw.
And then some string blah.
Famous last words.
Mm,
What?
no. Okay, apparently not.
String. Oh, what? Monad accept. Yeah, how do we throw? Is this going to tell us? Throw
B2.
something of type. So E. What? How do we see what constrains E? Epsilon, sorry. Oh, we need to find instances of monad accept. Can we do that? Instance accept.lean. Util basic tactic printer trace. Yeah, I was curious to see how easy it is to find stuff
Yeah, yeah.
in the IDE, but in this case, I don't think so. Is it? Development guide. No. Oh, doing that thing again. Accept. There we are. Throw can't divide here. Oh, but that's because we're in this.
Yeah, except.
All right. So
Yeah, fair enough.
yeah, that makes sense because we're not in IO. I'm assuming if we were in IO, you could do this. But yeah, it makes sense. The ID monad doesn't have any way of dealing with exceptions.
Yeah.
Yeah. Yeah, we're not allowed to infinite loop, so we can't implement like undefined.
Yeah, that's fine. We can. Oh, you can maybe say partial diff. Partial.
Partial is the other way, isn't it? So it means that it's not defined for some inputs.
Yeah.
But it always has to provide. It still has to provide an output.
No, I think you can remove that. Ah. Okay, I'm wrong. Again.
Oh, maybe I'm getting confused. Yeah, partial means, I think what you said it means. It means that it's non-total.
Yeah, but then you should.
So we could try
return
partial. Well, we could return something that was partial. So we could say, how do we do it? We say type Oh. Is that? No, we're not allowed. I don't. I just want to find like something that infinite loops.
Yeah.
I guess it can't figure that out.
Yeah, it's actually really hard to find a good data set. I don't want to generate this like in 2 languages. So I'm like, I know, yeah.
What we want is like lean.
Yeah, it's probably easy to generate, but it's just like, I really don't want to think about that.
Oh, we need mathlib for this.
Yeah.
Unless it's ended up in stud. Forward stud random. Oh, that's not Lee.
Yeah, Lee.
How do we find stuff in the standard library?
You just
GitHub.
Search, yeah.
We want Google.
Yeah, there's not that yet. We don't have Google yet.
Where's the search button? No. We have to use mathlib. I'm trying to see how good right, using mathlib as dependency. This might be useful anyway. Existing project, do this. Oh, but then we need to use the right version.
So you're building one now. Because why not?
Building what, sorry?
You're building a random generator for inputs.
Yeah.
Okay.
Well, hopefully there is
I like it.
Then we should do something like cache get. That's not what I expected to happen. Did it change this file? Yes. No, didn't. And then mathlib for random. What? I saw it was in here. Oh. Maybe
Okay.
that was. Maybe it was in there. Where I thought I saw it. Lean. 4. 2. Oh, this is the old mathlib, isn't it?
Mm.
Rand. Yeah, this is the old mathlib. I thought they ported everything.
No, not yet. But they should have random at least.
So let's see if it's in the same place. What is this? Force control. Control. Random.
Hey,
Okay. Rand. Where's the stud rand? Generate a random value of type A, rand bound.
yeah, so that
Fin,
for net,
rand-
it should work for net. Yeah.
Yes.
So you just need to assign it to a net. But
But he's not in IO. I guess it doesn't. Oh, it doesn't need to be. The seeding will have to be in IO, but the thing won't have to be in IO.
it's okay. We can
Honestly, see
provide
what
a seed.
happens.
Like,
Yeah. Oh no. Now everything is broken. Oh dear. That was a mistake. Improperly formatted manifest.
oh, just delete your manifest. Just try again. Delete manifest. Delete. Like clean. And just go again.
But then so this is wrong.
Oh, okay.
What? I just copy pasted that in.
Yeah, that looks right. Let me also go check.
Ah, okay. So maybe I was meant to do this and then you do lake update.
Oh, you don't need STD if you have mathlib, right?
Yes, that's
You can
true.
delete that.
All right, let me go away. Let's do that. Then we do the X thing. Cache. There we go. Let me get all the warnings. This cache thing is really nice.
Yeah.
It's something that Haskell does not have. I wish it did.
What does it do?
Well, it means you don't have to build mathlib 4. It downloads a binary for your architecture,
Okay.
an OS. So now it should build it quickly once we use it.
Cool.
Or maybe it's broken.
Yeah.
I have to read. This did work at some point. Okay, there we go. Yeah. That works. And then what did I want? Import mathlib. Mathlib. Oh, right. You can't put
Maybe
it.
mathlib.control, but random or something.
Yeah, it was complaining because the import was below open. It's processing.
Oh yes,
Finished.
yes.
Yes, it's already finished because it's using the cache. It didn't have to build this. Eval. I'm going to do random. This thing needs stud. Oh no. So we need a standard rand dot next or something. Rand dot.
Mhm.
Oh no, sorry, just rand bound or rand.
You might need, yeah. Okay.
Well, does this thing? Let's try this one. What does the square brackets mean again? Is this type class inference? Is that constraint? Sorry.
Go
Your
back.
random gen is a class. Yeah. I think this is like constraint on G.
Okay. Okay.
You end up in rand G. Well, let's try bool. No. Oops. Yeah, we're in this rand G thing. Rand G must be a stud one. Monad to generate random objects.
I think. No.
We do. Run rands. There we go. Oh, io.run rand.
What about random IO?
That sounds good. That in here.
I can't taste it, but it's what GitHub Copilot was suggesting. There's just called random IO, like maybe it's in that file, like one word. Okay.
We've got a run for it. Ooh, stud gen. Stud next.
Okay.
io.rand. There we go. That'll do, won't
Okay.
it? Where am I now? I'm in a different file. What is this file? What? What module is this? Randomly. It's different. Anyway.
Oh, this is in the standard library.
Oh, it was there then. I can just say
Rand.
Okay, fine. Now I can do rand nat. Oh, I'm not in a do block. I cannot be mutated.
Late.
Isn't that how we do bind? We have to say let, don't we? And unknown constant. So I need to import.
Maybe it's just rand, not rand nat, but
Okay. Yeah, it's going here. Oh, low high. I need to give it 2 arguments. There we go. Did I need to import stud?
don't even have what?
What? It's in the prelude.
Oh no, really?
How do we? Yeah. Where is this? Yeah, it's just in Lean in it. How did I even get to this file? Oh, I don't know. Anyway, we found it. Okay.
Wow. Okay, so
Oh, it was meant to be cached. Now building it.
yeah, I've got the same.
That looks random.
That's weird. You can do that. Oh, I need to do. That's my issue. Okay.
Yeah, we have to. You can just have let bindings,
Mm,
and then somehow, and then this of course is just in the IO monad anyway. If you
yeah.
want to bind, you need to be in the do block. Interesting.
Okay. All right. I've also got it working. Okay, great. Okay, so I have some Go code that someone used for a benchmark that I can show
Right.
you.
Sure.
So I'll quickly start sharing.
Mm-hmm.
Okay. So this is how they generate numbers. So they generate this list, okay? And then they say, okay, here's my benchmark function, given the numbers, just, oh, it picks a new target. Oh, it finds two random numbers in
Two
the
random
list.
indices, yes.
Yeah, and then just checks that they aren't the same and then returns that.
Yeah.
Okay, so how do we generate the numbers? We just make 10,000 numbers and they're each between some min and max.
Yeah.
And okay, this is very, very simple. Yeah. So we can do the same in Lean. This is just generate a list of 10,000 random numbers between 1 million and minus 1 million.
Mm-hmm.
And then we choose random targets. And then we run our function. And then we just see how fast it is compared to Go. I can show you the Go one for, let's say, 10,000 numbers. No, I guess we need to. So that's building and running.
Mm-hmm.
So I guess we need to build, unfortunately. Does that? Yeah, and then this is just running. So it's almost 2 seconds, right? So let's see if if Lean can get in the same kind of range, like less than 10 seconds. Like that would be good. I'll be pretty happy. So I'm gonna stop sharing and then you take over again.
Yeah, I'll just jump over. What we want is I can already use the sum thing to sum. I just need test data.
Yeah.
IO array int.
Yeah.
So min was
minus 1 million. Yeah.
Right, and then we want to.
Oh wait, it was 1 billion.
Oh, okay. Liam was going to look very good then.
Yeah. Well, actually, this is like the size of the array is the thing, right? So we're only
Sure.
generating 10,000 numbers.
Okay. Is there an iterate function? No, doesn't it auto-complete anything? What I want to do is iterate m. Is what we would have.
No. We're going to use a for loop.
Oh, okay.
We're doing imperative
Nice.
programming today. just
So-
today. Just today.
So we're gonna have an array. So there we go.
Mm-hmm.
I already forgotten how the syntax works. For I in, you said 10,000?
Yeah.
Do. And
So this is maybe,
in the monads. Are we still in IO?
yeah,
Can
it's
we do
fine.
IOE stuff?
It figures it out. It's fine. It's probably fine. Like, the
What's wrong with you? Oh, it thinks these are integers.
okay, there we go.
Ugh. Okay.
It thinks that they're nets. Yeah.
Sorry, it thinks they're nuts. Yes. And you have to be. Oh, we have to be. What? I want random int.
Yeah.
Surely there's a random int. Oh, great. Fine. So we need we can get random nat. Well, but we want actually negative numbers, don't we? So we'll. We could generate. What can we do? We can generate a Boolean and decide whether to make it negative or not.
Yeah, this is kind of good, and I'm kind of worried about the. Oh, there's Ewing64 to nat. What is this? std gen.
Yeah, so this will be. It gets the standard generator, I guess. It's not been. We have to set the seed at some point. But we got nats and we need ints, so we'll have to.
Okay, but I think Lean does the optimization of representing nats as ints in the background. So
yes, it does. Yes.
Okay, we don't have to worry about that. Okay,
So
then
we'll
then just
go
make
from
nats.
0.
Yeah.
0 to 10,000.
Yeah.
I was probably trying to help us. 0 to a billion. Right, so we get this. Then we say. We do it this way.
Yeah, I think we need to pre-allocate data though to have 10,000.
Yes.
I have no idea how to do that. But there's probably array make with a size or something.
Check it. Merc, yeah.
That's
no, it's convert to a list. What's the type of this?
So there's make.
I can't even see this. What? There's nothing here.
No, it's just below.
Oh,
there's comments in between.
Oh yes.
But if we go, let's make empty. Maybe there's.
Merc array with capacity. So capacity doesn't matter. Well, actually it does for performance, doesn't it? So we want to say. With initial capacity. See, so merc empty with the capacity. Okay, fine.
Yeah.
So where are we?
Yeah. Yeah.
You're not happy because you can't. This is not how you assign to an array.
Yeah.
Because it thinks it's a pattern match.
Yeah, let's go back to the array library and then just check if there's a.
Oh, now it's not letting me click on it.
Might still be open.
Disturbing. Oh, this is not happy either. Oh, it's because of type reasons. Okay. Push. Push will do. Because we just want to push it.
Okay. Yeah.
Let's see what else they've got. Set. There we are. But we have to give it a fin. Which
Well, if you go scroll down, there should be set exclamation mark.
Set exclamation mark.
Just guessing.
Yes. Yeah. I
Um,
guess right. So, but we have to use this in. Oh, this is. We have to use it. So I can't say data.set. I have to say. Oh no. Does it let me do that? Or do I have to say array.set and then give it the array?
I'm trying to find some
array.
examples.
The index comes first. Yes. This could be failing for. Right. This could just
it should be
unhappy about stuff.
It should be data.set exclamation mark index value. So yeah, that was correct.
I should be able to use this on line 12, or do I have to use this one?
On line 12, yeah.
I should go. Okay. So I should. And that's not. Oh, because it. Oh, this has to be a. Sorry. Yeah. The types. Well, we're saying this, right? So that bit's happy now. And then we can just this one. And then I need to do this. Okay. So we get this test data.
Or you can push. It seems you can, yeah.
Push.
You can push on an empty list.
And then push returns. I mean, none of these things are mutating, are they? They're just, you give it an array, it returns an array.
So I'm kind of wondering if you set, right?
Yeah.
No, it should be fine with capacity. But yeah. Yeah, let's try set first, see if it works. And then pushes our backup.
Yeah. We make it with capacity and then we return.
And we just need to add the bool. What I would do is I would make the max 2 billion. And then I would convert the random number to an int and subtract 1 billion. And then you can still have your array of int, yeah.
Say that again, what?
Yeah, so now we want to convert that v to an int.
Yes, so it's int.ofnat, I think, or ofnat is the constructor.
That sounds promising. Probably need to give vi a type to make
Yes,
offnet
yes.
be able to infer it.
Yeah, I mean
Right.
this should be this should be okay because this is
Yeah,
sort
yeah,
of the
no,
structure
it's
of
fine.
that.
Yeah. And then we set data.set with vi.
Minus.
Yeah, 1 billion. Yeah.
Okay, that's good.
Cool.
Nice.
That's our and now we need another one that is get target.
Yeah.
Also, IO is
So
probably
this one-
easiest. So
This one takes array
good question.
int.
It takes the array. Yeah.
It should
And it
do like
returns
this, and then it
two
returns two nats, two indices.
Yeah, 2 indices. Yeah. We can also just let it return the target. Actually, like we don't need the indices. We can just return an int.
Yeah. Good point. So we pick, right, so we pick a number between 0 and the size of the.
Yeah.
Oh, so this needs to be an IO.
Yeah. And we need 2 rands going. So
We pick 2 indices. Yes.
And then we calculate what their target would
And we
be.
check they're not the same, and then. So you need a while now.
Yeah. I wonder.
Is
Yeah.
inclusive or not? So we need -1. 0. I think.
Oh yeah. Okay.
Back to this.
Cool.
And then we need to check.
Yeah, I think we can do a recursive call. We can say if they're the same, call get target.
I1, I2, then get target.
I think for this we might need partial, but we'll see.
Right, yeah. Otherwise, we
just add them.
Yes, we get values. So pure I1 plus I2.
Yeah.
And then this is going to complain it's not. Oh.
Yeah, now try partial.
Yes. Partial.
Maybe this is the. Finally, okay, that's how you use partial. Okay.
Yes.
Okay.
Wait till it says I can't figure out what. Yes.
Okay.
Because this could go on forever.
Yes. Technically, yeah. Okay.
Right. So in the main, we do receive the random number generator.
It's okay. We don't need to do that. That's fine. Yeah, we just we loop 10,000 times. I think that's the important thing.
Okay.
Yeah, and then we want to call get target.
We need to get the data first.
Yes, we need to get the data first.
Yeah.
Outside of the loop. Outside.
Oh, sorry. Yeah.
Yeah. Otherwise, it's unfair. Very.
Values cannot be mutated. Let. I have to remember this error message when it says values cannot be mutated. It means I'm missing a let.
Yeah, which is very
not
weird.
In Haskell.
It's a very, yeah, it's the wrong error message. Yeah.
Okay, so we've got our targets.
Yes.
Then we
also need a
call.
let again.
Thank you. Yeah, I'm not gonna. It just looks too much like I think I do, and I think Haskell. Ugh.
And then we need to call our function.
To sum with values target.
Hmm.
And I need to ignore the return.
Yeah.
To void.
I think you can just
Pretend I'm in Haskell. No.
No, sorry. Let underscore.
Let's do this. Yes, with that, with the let.
Yeah, there we go.
Yeah. Oh no, this is pure. To some.
Yeah. Okay, let underscore equals thing.
Yeah.
Here we go. And then, just for fun, let's just print done at the end.
Nice. Okay.
Okay. Let's see it
Perfect.
run.
Let's see it crash.
Yeah.
What's the chance we get a seg fault?
Oh, no. Okay, one. Okay.
Oh no.
Okay, that's
What is
interesting.
it? So we're getting out of. We could be anywhere.
I'm gonna say it's the state. I'm gonna say it's the state.
Okay, that's good.
I think we need to push.
Where's this I? Ah. Oh, because this empty thing. Yes.
It's still empty. Like we've allocated the memory, right? But it's
then how
not
do you
all.
assign them?
Well,
Yeah.
you push into that memory.
Got it. Yeah,
right.
yeah.
But
it's a long time since I've used arrays.
It's still an empty array. It's just the memory is ready. It's ready to be pushed too, so we don't like reallocate all the time.
Yeah.
Yeah.
Okay.
Yeah. Probably.
It's good. We've removed one exclamation mark.
Yeah.
So capacity. This is probably redundant. Then we can just.
No. We want it. Otherwise, it is unfair as well. Like Go is also.
But it only does it.
Once.
Only does it once. But I agree. It's unfair.
It's a big array. So. Ooh, do it a little time.
Whoa.
Wow.
No, I don't believe that. No, I don't believe it.
Okay. I think
something's gone. Something fishy must be happening.
Let's print.
Are you sure it was only doing 10,000?
Yeah, let's print out the to sum, and I'll also add the printing to the Go just to be fair.
Yeah, this suspicious.
Yeah. Mine is doing the hash map implementation. There's nothing weird about it. Okay.
Well, of course, my implementation of twosome could be broken as well. So that's another possibility.
Yeah, it looks good. I'm just also going to change target to actually return the sum.
Oh, no. I know what's happening here.
What?
This is. Oh, no, it is called LeetCode, isn't it? Oh, let me just run it and see. I thought I was running my other example.
Okay.
Oh, there we go. So it's doing stuff.
Okay, I'm gonna.
Oops, I didn't time it. But I mean, it's printing stuff out. So it's doing work. I mean, obviously, it's much slower than the terminal is slow.
Yeah.
Right. Let me just double check. Oh, do you think because maybe this is never used, and so it optimized it away?
Yeah.
So it never calls this.
That's what I'm worried about.
It must be that. It must be, because that's literally like the startup time of the thing. like, yeah, I mean, if I just print stuff, if I just print done here, oh no, that wouldn't help.
So what idea I have here is to not overdo the terminal, but still make sure it's actually happening, right? Is let's just add up all the numbers that toSum returns.
Yes.
The toSum should return 2 values, right? Is it
Yeah,
captured
so it's
in
got 2 here.
Oh, it's capturing it in a tuple. Oh, very nice.
Yeah, in a tuple.
Yeah, so let's just add it all up and then print out the total at the end. Like, so then we're not spending all our time in IO, and we make sure it is actually going in there.
Sure.
Okay, but I can already say the IO is slower in Lean than in Go.
Right.
With the IO, it doesn't even make a difference to the Go one.
Oh, even in the VS Code terminal?
Yes.
Oh, nice.
Yeah.
That's impressive.
It's like 40 milliseconds difference.
Yeah, okay. So it's slow.
You should print out the total at the end just to be.
Oh yeah. Thing is that it's actually.
Oh, it's already enough.
It's already. It's So the actual IO bit is insignificant.
Yeah. So. Yeah, it's so Go is at 1.8 seconds and you're at 6.3, but we're on different computers.
Yeah.
So
I mean, we're not expecting it to be as fast as Go.
It's in the same ballpark here.
Yeah, I agree.
Already.
It's not that bad.
Yeah, but
I'm sure if you wrote in Haskell, it would be really slow.
Since we're so close, right? Maybe send me the code and then
Sure.
Just unshare your screen before you open your email or something.
Oh, yeah. Thank you for the reminder.
But then, yeah, send me the code and I'll quickly try to give us a on par representation, like on the same computer. But I'm impressed.
Yeah.
For a prover, this is not its main goal at all.
Yeah, it'd be interesting to compare it if you did calc with extraction or something.
Okay.
Well, maybe that would be fast. I don't know.
Calc extracts to
OCaml.
Yeah, the best comparison would be if we ran OCaml. If we ran Haskell, it's not going to be fair.
Sorry, Haskell.
Yeah, sorry, Haskell. Yeah. Okay, how are you sending this to me?
I'll send it to you by email.
Okay. Okay, good.
I just copy and paste the code in. Is that acceptable?
Cool.
Main file. Oops. What? Control C. Oh, Control C. I think that's it.
I would show everyone the Go code now, but I'm too afraid that I'll accidentally show my email. So. All right. Okay, I got it. Very old school communication here, like using email to send things around.
Should have sent you like a Git patch.
Yeah. Okay. Okay, I'm gonna close my email and I'm gonna share my screen. Well, I say that, but this needs to go here. Come on. Oh, here we go. Okay, we're getting there. Okay, so here's our Go code. Just for reference, we're not using this super fast Go version because that's not what we're comparing to, but we're using this with the hash map because that's what we're actually comparing to in Lean. And we have our Lean. Okay, there's
but you need to split this up into 2 files.
Yeah.
Or you don't need to do that, but you need to put the imports at the top.
Yeah. Okay, so this is just the code we just saw. That now let's see. Like bold. Cool. Ben. No, bold. Ben. I call mine app. Whoa. Okay. I think
What?
we
need that.
I need to read bold. One, two, three. I should just use time. I don't know why I'm not doing that. Okay, so there we have total. Okay. So this is the Lean code running. 6.4, kind of the same as on your computer.
Yeah, the same.
And then we build our Go code and we run that.
I think we have the same computer, don't we?
Yeah, probably. Right. Now that I think about it. It's now slower than it was before.
Oh, is that because you're sharing the screen? Because you're rendering.
Okay, no,
Try again.
Just felt slower.
Oh, right.
Yeah. Okay. I'm just having some minor time dilation. Issues in my brain. Now.
Yeah. So I guess what we learned as well was that the compiler will just optimize away stuff that's not used.
Yeah. But let's see it run 100,000 times now.
Mm-hmm.
And then we'll do the same with Go, just to see if it's not there's not some exponential issue. This is the best part of the stream where everyone's just watching, not even watching a clock, just waiting for something to finish.
Are we going to overflow int?
We're all like watching the microwave, basically.
Yeah. Well, we're going to overflow
watching
int.
Paint to Dry.
What happens when that happens?
Oh, this one, maybe.
Yes.
It's net.
There's probably nothing will happen. Oh.
Can't overflow. Well, I mean, in the background, it can switch to big int and.
Yeah, assuming they have that. Okay.
Yeah, there's no linear issue. And we'll see if the Go code overflows. But yeah, so you're not going to have super fast programs in Lean because I haven't spent years optimizing it, but it's actually very comparable. Yeah, 17 seconds versus.
Yeah, so it's scaling up.
Yeah,
the same.
But just 3 times slower than Go. Not that bad. Not that bad at all. I'm impressed. Okay, but Now we should tackle a LeetCode problem.
We should tell you. Let's do that.
Yeah.
Right. So we get to pick. Right, share. Yeah, it's a while since I've used Zoom, but I like the fact that when you share the screen, it doesn't share the window you're looking at. If it's
so
the
good.
participants, not the same as Discord, doesn't do that.
Mm.
At the start of every share, you always have like all of the, the mise en abîme thing, or you see the infinite.
Oh yeah, every time.
Okay.
Maybe let's take a 5-minute break and then pick.
Let's take a 5-minute break and then we can pick a problem.
Then we pick a LeetCode problem and then we solve it in Lean.
Okay.
Cool.
Hello.
Hey, I found a problem,
Oh.
but maybe you have a better
Are you
one.
muted or am I broken?
I am muted. No, I'm not muted. Whoa, whoa, whoa! You should hear me. I'm not muted.
No, nothing is working.
Hmm. Hello.
Oh, of
I can
course.
hear you. Hmm.
Hmm.
Hello. 1, 2, 3. No.
Hello?
Yeah. I can hear you.
Oh no. I don't hear you.
Maybe rejoin.
Let me rejoin the call.
Me just staring at the screen and one other person watching. Yeah, so I found this problem, but we'll see what Paul found.
Hello?
Hello?
There we go.
Nice.
We're back.
Yeah.
Reverse integer. Okay.
I don't know. I found this. It's
Yeah.
close to the top of the list, but yeah. It's using strings, and we haven't done that yet.
Ooh, that's good.
It should be easy in any language, but will it be easy in Lean? Well, at least I would do this using a string, but you technically don't need to.
Yeah.
Would you like to try it?
Yeah. Yeah. Back.
Yeah, somewhere like it's yeah, very close to the top.
We take an int. Let's do it. This didn't need to be partial, did it?
Oh yeah. Yeah. Yeah, and it isn't int because it can be negative.
Okay.
Yeah, in which case we keep it negative, but the int part reverses.
Ah, okay. How do we make a string out of?
There should be well, I mean, this is just how I would do it. I would
Yeah.
convert it to a string
Makes
and then
sense.
just loop over the number and start multiplying by 10, I guess. Like, I mean, because they want you to, I mean, is this problem lame or is it just me? Like you just convert to string, reverse string, then
Yeah.
remove
top.
minus sign at end and bring to front. And then, or even remove it before and bring it back. And then just check if it's outside of range. Like return the 0. Like what's the no, I don't know. Like obviously there's some catch here, but is there a better problem?
Well, maybe we should do this one. I mean, just to see what the
Okay.
string API looks like.
Okay.
Whether there's a, I mean, how do we convert this to a string?
Yeah.
Oh, look, it does use GMP. That's nice.
Okay. Yeah. Okay.
So int must. String? No. That'd be useful. Can take the abs.
Yeah, that will be helpful, yes.
Yes. Let's see if nats.
There's a string.toInt. So
so toString. Substring. What? Why am I? Oh, I'm in preludes. That's why.
Oh.
Oh.
Maybe there's a from string. Of what did they say? Of
So of-nat was the constructor for int.
There's no int of string. Okay.
No. But it must have what's the thing, you know, when you do the string interpolation, what function does it call when you do that? What's the that S thing?
Yeah.
If you
show, is there a show toString?
Yeah, toString. So it must it's just
Yeah,
calling.
Yeah, there's no, this email. No.
Because it's a macro, this S thing,
and
it does expand interpolated str. I don't know what I'm looking here. Okay, well, let's look up. What do I do? There's something there.
.repr.
ToString mentioned here.
It's representation, so it's REPR.
Expressions inside braces are converted to strings using polymorphic method toString. So I think int will just have a toString method on it. That's my interpretation of that. But I think, yeah, the class is called repro.
Yeah.
Maybe.
The dot repro works.
But will that put quotes around it?
Okay, I'll check.
Yeah, let's see. It doesn't have a toString method.
No, it doesn't put quotes around it.
Okay.
Yeah.
But how do you use it?
Yeah, just like that. So just where you said, yeah, on line 16.
It's confused.
Okay.
I mean, the value is confused.
Okay.
It thinks I'm trying to write a float.
Okay, on line
that doesn't work.
On line 16, you can go late s : string.
Nice.
equals, yeah. And then, yeah, that should work.
And then this is it's actually a list of char.
I hope so. Yes.
Yes. So does it? So how do we have to pattern match on the constructor to get the list of char? Or does it behave like a list of char?
I wonder if we can use a for loop to loop over it.
Ah, yeah, because it will have that whatever the thing it needs.
I'm wondering if that's possible.
Yes. Let's see. Let's just try. I'll do with this with a C. Invalid do application. Expected type is not a mode of application int. Oh, because I need to do this gubbins at the beginning.
Is there a for in range or?
Oops. Yeah, it failed to synthesize instance for in notation.
Yeah. That's what I'm getting.
I'm not allowed to do that. So can I? Merc iterator.
Oh,
What the hell is this though? Oh, they're magic brackets. What is an iterator? String pos.
yeah. Just the position.
To do. But can I? Is this a thing that I can iterate over with a for loop, or is it just some?
What is the
I think
method?
it might be some.
Dot make iterator. You're saying?
Yeah, so it doesn't have a for in. I think this is something else.
I'm trying to search.
Yeah, so for in m row alpha is a type class which supports for x in excess notation. So we have to have a for in. So it'd be nice if a string had this instance.
Yeah, exactly.
But maybe it doesn't. So how? But the list must. So I can pattern match on it.
Yeah.
String dot merc l or c's. Yeah, so now it's just
That work?
yeah, I think it worked. Yeah.
What is
So it sounds like this thing should have a for in instance would be nice.
Yeah.
Nobody does this kind of thing, though, in Lee.
No.
I can see us, but we might do it at some point.
Yeah.
With the regular expression stuff.
Yes. Oh, that's very cool. Okay. So now we can loop over it. Now we want to create a new int and a mutable int.
Yes.
And then convert each character to an integer.
Yes.
Yeah, so we need to say like lit mut reverse or result. Yeah, just like you did there. Yeah.
Char, I assume a char is what is a char? Char could be a int anyway.
A char has a toNet, but that's probably not what we want.
No. Oh dear. Oh no, Lee has a vowel. Oh, there's a Unicode scalar. Oh dear.
Int of char. No. Not a thing. Oh.
This is more like what is it called in C? It's like I
Ord?
to L. Well, that's
Ord?
code point, isn't it? So we'd have to.
No, it's not ord. Oh, you can always subtract 97 or something. But it seems very...
Yeah. Like, I don't know if it's got these like things that the I2 in C it's called iTalk or C toy. No, this is not good. Okay, so maybe we have to operate on the integer itself and do the modulo stuff.
Oh, yeah. I think you're right.
Because yeah, we were relying on the standard library having this like C to I thing.
No, maybe there's... I think the string has toNet.
Oh, if the string has toNat, we can just make this into a string.
Yeah. So
do toNat. Okay. Yeah, but what? Oh, the string. I'm not in string.
Yes, it does.
Oh, okay.
But so does C. The char also has toNet.
Yeah, but that will be the code point, I assume.
Well, let's
have a look.
Let's see. I think we have to. The only way to check is actually. Oh, what a pain. 7.
So char of nat, is that what we're saying? Or is no, we're going the other way, aren't we?
Yeah.
So convert when we go char of nat, it interprets the nat as a code point.
Okay.
So if it goes the other way, it would do something different. That would be strange, but
okay,
it
so
could do.
You subtract, you take the 0 character and you subtract its to net.
Okay, let's do that.
Yeah, value from it. All right, it's been
Okay.
staring me in the face here, and I've just not been looking.
So 0 code point, 0 net. I've lost the plot, that one.
Yeah. So now you can say the digit is C dot, like in the loop,
Yes.
we can create the digit.
Yeah.
And then we can call it, well, then we say C dot to net minus 0 code point. Yeah. So now we have the net.
Digit. Yeah, so I need to have an accumulator for the tens. Right. And I'll do
I think we multiply the result by 10.
oh. Result by 10. Oh, okay. Yeah. Yes.
And then we just add the digit.
Yeah.
And then
When
we
result,
end, when
I
we
need to start with 0.
Oh yeah, that works. Yeah. And now there's the negative. Sorry.
So then it's result that comes out at the end.
Yeah, so this should give us kind of the same number, right?
Oh, we need to reverse the.
Yeah, but it's just, it's a start. It's a start.
Yes,
right?
yes. Let's
So
try.
let's just check if this works.
Yeah. Then we'll need to deal with the negative.
Yeah, and the out of scope.
Yes.
Yeah, but
when we do this, we have to check every time we do this whether we're still in range. Every time we multiply by 10, add the digit.
Yeah, so we can already do that if we want.
Right, so what's the range? 2 to the 31.
Oh, whatever we decide it is, right?
Okay. Well, how do can we write literals? This?
That's a good question. I think maybe we can just do the little cap.
That would be nicer. They did that. Yes.
Yeah, nice.
Not happy with that. Oh, because it thinks it's an int. It thinks it's a nat. Mm.
Does it work?
So h pound nat int. So it's confused because it thinks this 2 is a nat.
Hmm.
And this is a nat, and then it wants to give an int at the end. Okay, so here we've got to do int dot of nat.
No parens.
Well, I need parens probably for the -1. Okay. And this is int dot neg. Int dot of nat. Okay.
Nice.
Yeah, what do we do if we go out of range?
And we just return 0.
Yes.
I think the idea is that you like your int is well, okay, but let's start here. Like this is fine. But I think the idea is that you're using an int that only has that maximum.
Yeah. So this is not really right because we
can't.
couldn't do this in the first place.
Yeah,
Yes.
yeah.
So we got to do. The result has to be.
Yeah, it's pain. So let's just go like it's just such a shitty if condition.
Yeah, so we have to do that. So result has to be. We just have to. Result minus digits divided by 10 needs to be in the range. No.
I like
something like that. Yes, if result minus digit divided by 10 is in the range, then it means that after we do all this,
I think you can also check, right? If sorry, just 1 second. So if we do this result times 10 plus digit, right?
Yeah.
Then it overflows, right? In the case that it's outside of the range. So you can kind of just go, if it overflowed, return 0. So you just need to be able to check, this was the previous result, and it was positive. Then I added another digit to it, and it became less than what I had. So it overflowed. And then the reverse for negative.
But can we assume that that's the behavior of overflow? Because it just says. Because it's like if you're on a 32-bit integer, depend.
Yeah, and you are given.
Yeah.
So my answer is just use a 64-bit integer and like enjoy the rest of your life.
But it says assuming the environment does not allow you to store 64-bit integers.
Okay.
They caught you.
Okay, so then I'm going to use the fact that it overflows.
Yeah, but you can't. Well, but it could say your environment explodes instead of overflowing.
Hmm.
It doesn't say that it overflows.
Okay, then.
But we can just rewrite the question. So
Yeah.
I
So
think if the where are we? Yeah, if this plus digit wasn't there, then it would just be checking that result divided by 10 is within the range.
Yeah.
That bit I'm confident about. The digit thing, adding the digit thing is the weird part. So when would it?
So then you have to. So you take the range max, right?
Yes.
You subtract a digit. No. You divide by 10, and then you subtract the digit.
Yes.
And then you go, is my result smaller than that? Because then we're fine.
Yeah. Yes.
Yeah. I think that's kind of what you said before. I just couldn't.
Yeah, I think you said it more clearly. So range max. So, well, we have to check both, but results bigger than range max divided by 10, subtract digits, then return 0. Then we got nest.
No. I don't think you need to.
Oh, because this is this. We don't
This
need.
is lean.
Nice.
Yeah.
This is lean. Thank you, lean.
Yeah. And yeah, we just need to do the same for
Range min. Oh, is this minus or plus? Still.
Yeah, I think it's still minus. Because that's the reverse of the operation. Doesn't matter.
Yeah. Oops.
Ooh, no. Is it the reverse of the operation?
Yeah.
Let's just do it for positive numbers for now. Like, and then okay, we'll come back.
That's already nice. That's already nice. But we don't need an else here.
Yeah. Okay, maybe we also do a string dot reverse before we start.
We can reverse the list. Oh, is there a reverse on string?
There should be.
Okay. So I can do reverse. Oof. That's a string, right? Is it a string? Yeah. Reverse. List will have reverse. Maybe we got it. Maybe we have to do that because it doesn't like. I think this is a problem with type classes.
Yes.
You can't figure out what's going on like very easily. Because it could be like, oh yeah, string doesn't have a reverse method, but somewhere there's an instance of like reversible implemented. It's like it's not so easy to find out.
Yeah.
Okay.
Yeah, a lot of languages with interfaces have this problem though. It's just we use classes interfaces so much in Lean that it is exacerbated. Like it's just so much worse. Okay, we've got that. Okay, and that works. Okay. Let's do a big one. Or yeah.
So I should be able to do 2 to the 32. Oh yeah, with the hold on, but I want to.
Yeah.
I want a 2 to the 32, but then I got to reverse it.
Yeah.
Yeah, okay, so I can, let me just. Well,
Yeah. Oh, yeah. Just copy paste and do it manually.
what? Well, maybe I can copy it into here. No, that's of course. Hold on, because it's working.
Yeah, it's kind of
I
working.
don't want it to work.
Yeah, just turn it off. Yeah, there we go.
Assuming that, okay. So now
Yeah, there we go.
it's a bit circular.
Oh, yes. Okay.
What am I doing? I'm plugging that
Yeah,
back into it. So
paste,
there we go.
paste. Yeah, there we go. I think it needs to be bigger or equal though. No, only bigger.
How would I know? How would I see that? If I make,
So this is equal to 2 to the 32 minus 1, right?
yes. Anything bigger should also.
To make it a 3 at the end.
Yes, 4.
Yes. Okay.
Nice.
Make it. Sorry. Sorry. Yeah. Make it what it was.
4.
Yeah. And then at the start, make it a 4 instead of a 5.
Ooh.
Yeah. There we go. A 3 or a 2. Just like an off by 1 thing, or no?
What? This is just not really. Now I'm confused. Oh.
Yeah.
What? It's not. Nothing is. Oh, there we go. Oh, what's going on here then?
What was the original number?
No, hold on. But this could have still been okay because we want the original 2 to the 32 minus 1. Is this? Assuming that's this one. Right. So let's take this one.
Yeah, just commented there.
Yeah.
I wanna see it.
Right. And then I forgot what I was claiming. Let's get the reverse.
Yeah, so that one is fine.
Right, this one, reverse. Should be this.
Okay.
Just can't be bothered to type it. Okay. Right. And now what was broken was I changed the 4 to a 3.
Yeah, no, we have to paste in the reverse.
Oh, sorry. Yeah, so this put 3 was okay.
Yes, 3 was
4
okay.
is not okay. But yes, but this is okay. Yeah, even if I put this to 3. Oh, no, that should be okay, shouldn't it? What's happening then?
So we get to 9, 7, blah, 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 right?
Yes.
And then we're saying, okay, the next, now we're getting to 5, 9, blah, 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 right? And the next digit we need to add is a 4. Say, okay, we're going to times 10. We get 500 plus the digit. And we ask, is the result bigger? No. Oh, wait. Okay, so we get to we divide this number by 10, this 429 thing, and then we subtract a digit. Should but it shouldn't be touching that 9. Shouldn't we first subtract a digit and then divide by 10? Okay, this type of thing.
This is horrible.
Yeah. Maybe subtract a digit and then divide by 10.
Give it a go.
Yeah, just give it a go.
Yeah, I mean, if you look, oh, well, let's just try it rather than try and convince myself.
This is like left and right. It's too hard for me.
Because play.
Okay, now.
Oh, what? But now we shouldn't be allowed to do this.
No, that number is fine. We're not allowed to do one larger.
Nice. Good points. Yes.
Yeah.
So justification is, look, you kind of rearranging this thing. Maybe.
Can you also just test the other side? Can you make that 5 at the end a 6? Oh, the 5 at the start, sorry.
Yes, that's also, because that's one.
Yeah, that's one more.
Yeah, one more.
Okay, cool. I'm happy. Okay.
Nice.
Yeah. Okay, that was pure luck. There was no, I didn't calculate.
Well, I mean, yeah, I'm sure if we like looked at this and like basically if we rearrange this, we subtract the digit and divide by 10 to get the pre-image.
Yeah.
The operation. So it's probably that, but that's not. This is not a proof.
No, actually not. Yeah, think about it. Like the last thing we did was add 10. So the first thing we should do is subtracting. Okay.
Yes.
And
something
now,
like that.
Now we can just do it for the negative number. So what we want is to say,
if we less than.
Yeah, but first we need to just handle a negative number.
Oh, okay. So we can do abs first.
Yes.
Oh, but is that going to mess? But then we'll have to. Right, if we do abs first, we have to keep track of whether we were negative.
Yes.
But then how does it? Then it's going to affect the. It will affect the range min check.
Yes.
Somehow, which my brain is failing to grasp. Where do we? How do we?
Let's just start with isneg, and
yes,
and make sure we have an absolute. So isneg is just whether the absolute.
Take the absolute.
Yeah, is the absolute.
We need the abs anyway.
Yeah.
Sorry. Abs nat. Oh, nat abs. Oh, but now we're nat. Now we're natty. Now we're natty. This is fine. I abs repra, because that'll give us a string anyway.
Okay.
This is just I abs. Oh, that's not going to work either, is it?
No, just I not equal to I abs.
Oh yeah. But this is a int and this is a nat. How is that even possible?
I think it does some.
But does that mean? But is it eq? They have to be the same type or different?
I think it does implicit conversion of the
Oh,
neg.
okay. Oh, we can try. Let's try it. What can I do? Int dot of that one.
I know parens.
Oh, yeah. Very
What have you been
confused by
coding in,
that.
man?
Yeah. Bash. No, that wouldn't help. That wouldn't be a problem.
Mm,
Okay. That's a nat, that's an int, they're the same.
yeah,
Okay. Convinced.
I think I read it somewhere, but forgot where.
I'm convinced it's wonderful.
Okay, so we now have is neg.
So how does it? So we definitely want to.
We first final thing we have to do before we return is check that.
So yeah. Is neg then. Well, we're going to have to do this before, I think. Because this. Oh well, we can try it.
So am I correct in assessing here that negative numbers have more range than positive numbers?
Oh, it's not gonna. Negative. Well, it depends if you think that 0 is positive or negative.
Okay.
So I think they're the
I don't
same
think
range, but yeah.
I don't think it's either. So
well, according to our code,
yes.
positive. Yeah.
Okay.
So.
But so we have a little problem here with our range check, right? So there's like a off by 1 error problem.
Oh, is that okay?
Because
Yeah,
the maximum we can store in result is 2 to the power 32 minus 1.
Yeah.
And what we want to store min yeah.
Oh no. No, hold on a second. We can lawyer our way out of this.
Yes, definitely.
No, hold on. It says it does not allow you to store 64-bit integers, but we can store a 32-bit integer. But it's 2 to the 31. So the range is smaller than what we can store. So we have more space than we need. So our range check was wrong, but we can still use a 32-bit integer. So I think we're still okay. So we're using 32, it should be 31.
So I
think we're safe. We're safe.
Okay, fine. Okay. Okay, well they could have been much nastier about this.
They could have been. Yeah. It's very
Okay, well then we could just do copy and paste the if that we have there for range max. And
yes. Hold on. Hold on, no, but range min is negative. Oh, so we have to multiply.
No.
Oh my God.
No, we don't need to. I think we can just go range max. I think we're done. Yeah. Oh, okay. We need to say if it's negative.
Yes.
Then we need to add 1 to range max.
Yeah.
1 to result or something. We need a +1 somewhere.
So we already know at this point. Whether we're positive or negative, so we can just set the range here.
Yeah.
So here's like the range max, range min, and then we can say let range if is neg.
Okay.
Right.
Yeah.
Range min as
Yeah, just need a lane. Yeah.
yeah. I can say range here. Actually 2 to 31. Oh, I recognize this number. Let me reverse this. You are this one. Okay. Yeah. Okay, so minus what we're not allowed. Ooh. This is negative less than or equal to. Okay. So if I add 1 to this guy. Oof. No, oh, it's subtract 1. I don't know what I'm doing. Oh. No. No, it's definitely add 1. So we're... Oh, I forgot to add the condition back in.
Yeah. But
okay, so this we should be allowed to have this one because this is just the reverse of.
let's just go look at your range min. Like it's still negative, right? And our
Oh, sorry. Yes, yes.
yeah.
This is mine. This is okay. Need to make it more.
What about the 9?
So this one is the reverse of 2 to the. Damn it! This is 2 to the 31 minus 1. This is.
Yes,
this
exactly.
This is 2 to the 31.
Yeah.
So this is right. Okay, good.
Yeah. Where we did it.
We did it. So this was the hard part.
Yeah.
It's the stupid condition business. Yeah. Okay.
So yeah, this lane problem was very hard actually. I was wrong. So that's good. Oh, we did it.
I think so. Well, I mean, what did we use from Lean here? I mean, the thing is like, so we get these coercions for the EQ type class, but not when we're doing not for the exponent type class, which is a bit annoying.
Yeah.
Because here it should say, oh, you're using a, I don't know. Well, I don't know. Not a fan of the coercions anyway.
No.
So, but this is when you're using literals, I always think that then that's the thing that's okay to do coercions with. Because you're saying like, well, I have a literal on the right-hand side. It can be an int, So I'll just interpret the literal as an int.
Yeah.
So it's not really coercion, but it gets confused. These are always ints.
Yeah.
But
when
when you actually do a negative, this I guess is going to be an lit. This is an int. It doesn't explode. But
yeah.
this is a nat.
I think it's just the POW that's not the.
I think it's the POW. So if I click this, okay.
I don't know. I mean,
I
just
don't even know how you get there. Yeah, but I agree that it doesn't have a. Maybe you could just implement npow nat int and just do the thing, or maybe just no one's got around to doing it.
Yeah.
It wouldn't surprise me.
Yeah, I think there's a lot of those cases.
Yeah.
This is not the typical lean use case. It works pretty well.
Yeah.
The speed isn't bad either.
Yeah.
Yeah. I think the next time I have to study for coding interviews, this is what I will use. I mean, if I have to do this on a whiteboard or in a code editor, they're gonna forgive me all the things that are irritating here.
It's actually a good tip.
And but I'll get to use some types. I'll get to use imperative programming and mutable things that I need for these stuff. Well, not need, but it's preferable for these types of problems when you're in a rush. And yeah.
Well, it's not just that though. When you think about, I don't know, this is somehow, nicer than a fold. You don't have to remember like the order of arguments, which is the accumulator, which one is the new value. It has advantages over fold L, fold R.
Yeah.
Because it's a lot clearer. There's the syntax. I don't know. Maybe just me. I always get confused with fold L, fold R, which way round the arguments go.
I know it's true. It's true.
Every time I have to look it up. I need to come up with a mnemonic. Like L, which is it on the left or the right? The accumulator.
I think that's the mnemonic is the accumulator, or the other one is on the side of the L or the R.
Right.
Because they switch.
Well, which one? Yeah. But I think this is just, don't know. You're not going to have a problem remembering which one is which one is which.
I think Erlang gets around this by not using fold a lot, because the way to define functions and the pattern matching is so concise that you usually just prefer, I'm going to do a fold. Let's just define a function that does that, because it's so quick. Where, I don't know, we don't do it in other languages, but when I was doing Erlang, I was reaching for this fold, but the Lambda syntax was so clunky compared to just redefining a function, where in Haskell's like, I can go, it's actually, the Lambda syntax is really nice. So I prefer folds. But in Erlang, the Lambda syntax is not nice. So you just write them manually. But writing the fold manually is actually really readable, and you never forget which way the arguments go because you're deciding every time. So I don't know. It's but it's really nice that this for loop gets converted into a fold for you.
Yes.
And
we actually have this in Juvix as well.
Yeah.
We have things called iterators, so you can actually define. So the user can define a for.
Yeah.
Nice. And the syntax would look more like you have you can have like a list of accumulators here with, so it would look like this, and then this. But the user is able to define this syntax. So you can have iterators with a certain number of like initializers, and then this just implemented using fold. It's just equal to fold.
Very nice.
So this is, we have it for map and things like that. It's just, I don't know, easier.
Yeah.
Syntax. And then you don't even need this milk thing. It's just,
that's exactly what I was
it's just syntactic sugar for a fold with a lambda with a certain number of arguments. But it's,
it is pure. You are just actually doing a fold with named arguments.
Yes.
And then you're going, let's just make syntactic sugar for a 4 for it.
Yeah.
You're not doing early escape or anything else, like.
No.
But already,
no. So we don't have that. But it's already a lot more familiar to people than trying to get them to.
Yeah.
Well, not just for people, but for me. I don't know. I like it like this.
Yeah, for non-people.
Yeah, I mean, I've used Haskell for a long time now, but still, I prefer this. So, but the early return is really nice.
Yeah, the early return is very nice.
Yeah, continue break. So this is more like a for loop, and this is more sophisticated, right? You've got this for in type class business.
Yeah, it's pretty impressive. Cool. Well, we did LeetCode exercises in Lean, and we didn't actually run into any blockers. Many stumbling blocks, but no blockers. And
yeah, I mean, okay, I cheated a bit because I did some of this beforehand. But this came from
that's fine.
Walter tweeted about this. I'm speaking to the audience now. Yeah, Walter tweeted it about this syntax for doing this imperative stuff in this do block. And then this ID run is useful when you don't actually, you're not in IO. You just have,
Yeah, I didn't know about that. That's really useful. But yeah, cool. I'll see you next time, I hope. Hi, Jimmy McNulty. Hi.
Oh, we have a viewer.
Yeah, hope to see you next time.
Yeah.
I'm gonna end the stream. Goodbye.
Bye-bye.
I don't know. Wait, no, that's not how I want to end it. Always